Hello, so this is episode 2 of building a humanoid robot arm, the right arm, from here to here, all the movements. So we made some changes to the degree of movement, and we also made some changes to the design a little bit, and we did a lot of design when it comes to the rest of the joints. I don't know what's gonna power the arm yet. Probably some kind of servos or motors, but I don't know what kind I'm supposed to get. I don't even know. I don't know anything from just the how the robot's supposed to move. So when we get there, we'll cross that bridge. I like my rifle. I don't know. It might be real, it might not be real. Who knows? It's Canada. Who knows? So what's up, everyone? So degree of freedom. We're gonna just state the changes we made here. So as you know, we have all these movable joints here for the four fingers and for the thumb. So the changes made is how the wrist works first. So there's gonna be a joint that moves the wrist like this. There's gonna be another joint here that moves the wrist sideways. I forgot about this other one that rotates the arm like this. So it takes it from 13 to 14 degrees of freedom because of, I forgot about that. And for these fixed joints that I had here before that the fingers were still like this, that might change in production. So put in mind, so it might go from 16, 14 to 4 more degrees of freedom. So here, I kind of got, I kind of like settled on like an arm design, like a thumb design, how the thumb should move. I don't know if I covered it the last time, or maybe I'm just making the explanation of the changes now. So it's going to have a fixed joint tool, as I said, subject to change in production here. So this thumb here is going to just be at an angle, and generally the hand is at the thumb here is at an angle than the other fingers, as we said before. So it's going to be a joint here and a joint here, but there's one more joint right at the end here. This joint is like it's curved. It's a different joint. It doesn't work like this too. It works differently. So this joint is curved. So it's just going to pull in the thumb in and out, in and out. That's for this last joint here. Why this one and this one is here, sorry, here and here. So there's a joint here, to be joint here and a joint here that folds in. Then there's one more that pulls in. So it's one here, then probably one down here that pulls it in. So that's it. So, but as I said, let's see how it goes in production. So next paper. This is the idea of the fingers. So this is how the four fingers will be designed. So we have our fixed joint here. So there's nothing to move here. It's just at an angle, listen, which is here, as I said before. And we have two joints here, which is this one rather, and this one. So this one this way and this one this way. It's gonna move by a single pulley or like a also. So this is the pulley, the pulley rope. It starts from here and it goes down to the second one, goes on a loop and goes into the palm. So let's not make everything concrete yet, but this is how it's supposed to work. So it only has one system to fold the finger in. It doesn't have another like pulley system to pull the finger out. It's not, or like it doesn't have that. So what we're going to do to achieve the finger going back up is we're going to put, you know, those springs that are like this. Yeah, I'm going to have that here and here. So it's always going to keep the finger straight. So the motor and pulley that we're going to use is going to act against it and pull the finger in. So once you release power from the motor, it slowly, or once you release the string from the motor, or like the pulley, so the the springs here will slowly open the arm back up. So we don't rely on any other motor to like pull it back out. It goes back by itself. As long as you take and take some energy off the motor, or like you roll out the string on the, let's call it servo, string servo. So that's how that works. So this is just an expansion of this. So here, one whole part. So this wheel is going to be attached to here. This one is going to attach to like this one to get together. And basically, so this is going to here, this is going to here. So it rolls like this. Yes, sir. Then the spring and these are the springs, and this is the, I didn't put the pulley here, I just put the springs. So this is not like the hard casing design yet. I'm just trying to make sure I understand how everything should move. So this is for the thumb. So these are 4 fingers. This is for the thumb. So the thumb, as I said, fixed angle here. 1, 2, 1, 2, folds in. Then this one, if you notice, this circle, so folds in one direction. Then this one pulls in, so it pulls the thumb, let's use my right hand, in. That's this one. Pulls the thumb in. This is like a drum. It's just like this, but not facing the way they are, or facing the other way. So if this has it's like 90 degrees, or like 180 degrees or so of what these two are. So, or 90, I don't know, I think it's 180. So this folds in while this pulls in. So this folds in, this pulls in. So, and this is just a more detailed design of that. Oh yeah, I can just zoom in. I should have done this. So this is just a more detailed design of that. Just me trying to visualize what's in my head or what I've seen. So that's it for here. Then the wrist. This for the wrist. So looks all shabby. Let's just skip this and just go straight to this one. This one makes looks more understandable. So for the wrist, we have this pulley system here. So all this is attached to the arm, like the hand. This is attached to the hand. So this and all this, they're all fixed. So once this rotates, the whole arm rotates. So once this rotates, the whole arm rotates backwards. So then once this rotates this way or this way, the whole arm goes to the side. So that's how this works. And this is just like they go into each other. So there's a string going this way, and there'll be a string going this way, but it's going to be like a whole loop. And if you notice here, there's no spring holding. It's going to return it to its natural position. Yes, it doesn't have here. So it's all going to be like high tension, and it's not, and it's going to be like on a, like, you know how pulley work, like a belt, a motor and a belt. So the motor is going to be like a step. I think it's called a step motor. They don't just spin, like they spin and they stop at where you stop them. Yes, and so so the whole arm will move and stop where it is, move up, stop where it is. So it's not like it doesn't freely spin. So that's I'll buy the exact motor that should do that. So because of that, we don't have any spring to return the arm to a fixed position. So wherever the motor stops is where the arm will stop. As I said, subject to change, anything can happen. Then we have the last design. So After you leave here, with all the movement we have covered, the next will be the arm rotating this way, back and forth. So how do we achieve that? Let me zoom in because this is a bit, okay, not too complicated. So all this here is all one fixed, it's all fixed, and this is the hand, all this is fixed. So whatever this rotates to, the whole arm will rotate to. So this is what they call a bevel gear. Okay, I did study engineering though, but not the like it doesn't really count to be honest. Yes, and I studied engineering, but that's why I know how to prepare bevel gears and stuff. But as I said, it doesn't really count in like how I study engineering. I shouldn't still know stuff, system, but let's move on. So there are two bevel gears here, Sam. So the design for how this will work is this bevel gear has a pulley on this side and a belt and pulley system, and it goes into the arm. It goes into the other part of the arm before the wrist, and there's a motor inside, kind of like a step motor, like the same way. Rotates, stops, doesn't just rotate like continuously and it's slow. Then as it turns this bevel gear, which turns this bevel gear. So if you don't know what a bevel gear is, if you're watching this video, you probably know. So if you know it's a gear, there's a normal gear, but it's at an angle. So when they're both at an angle and they hit themselves, they run each other. So this whole arm, all fixed one part. So let me try and explain this section now. So this and this tube here and all this are together. Why this goes through it? There's a design I saw that I'm trying to replicate, that I saw online, that I'm trying to use to replicate this. So this is how this all works. That is cool. So probably when I do like an expansion design and stuff of it, you understand it more. So this is where we are now, and the next step will be to, I think I don't actually know properly what the next step will be, but it might probably be detailed design of what we have covered, like proper design that I can follow and build. Then what kind of materials I'm going to buy to just do the mechanical part of it. No motors yet or anything, just gear, pulley, like what kind of materials I'm supposed to get. So we're going to do that, like since some of them really rely on friction, like here, all this, like you need this can't just spin on its own or something like that. So we have to make sure whatever pulley system we have is like the friction, like we have proper friction so that the arm doesn't just spin on its own. We won't if the gear is not moving. So we'll probably get like a pulley that has like threads on it, understand, and a belt and pulley has threads on it, something like that, to just ensure maximum friction. Understand? So that's where we are now. So next will be detailed design that I can follow and build, and all the materials that I'm going to buy. So those are the two next things that we're going to do. And after that will be building. So, thank you.